Good morning, students. Today we are going to see about adiabatic demagnetization. Before that, what is cryogenics? Cryogenics is a branch of physics that deals with the production and effects of very low temperatures. In the early history of thermometry, ice was considered to be the coldest and its temperature was taken as the lowest temperature. So there is no minus degree temperatures. Nowadays we are all know that the minus degree temperatures, but in the early history they think that ice was the only coldest and its temperature was taken as the lowest temperature. It was Fahrenheit who first experimentally demonstrated that a mixture of ice with common salt gives a temperature of the order of minus 18 degree Celsius. Later, temperatures lower than this temperature could be attained. The general principle of protection of low temperature is to remove the heat content from a body. So, this is the general principle of the protection of low temperature. Then liquefaction of gases. For a long time it was thought that air remains in the gaseous state at all temperatures. But Andrew's experiments on carbon dioxide lead to the discovery of critical temperature. What is a critical temperature means? It is the temperature below which a gas can be liquefied by mere application of pressure. But it cannot be liquefied above the critical temperature. However, larger may be the applied pressure. Below the critical temperature, the gas is termed as vapor, and above the critical temperature, it is called a gas. Note that below the critical temperature, that is Tc, critical temperature is represented as T suffix C. Okay, below the critical temperature, the gas is termed as vapor. Above the critical temperature, the gas is named as gas. Liquefaction of gases. So the liquefaction of gases is linked with the production of low temperature. Okay, so the substances which are gaseous at ordinary temperature can be converted into liquid state if sufficiently cooled and simultaneously subjected to a high pressure. So here the substance is simultaneously cooled and subjected to a high pressure. There are various methods of liquefaction of gases. First one is cascade process. Cascade process can be used to produce very low temperature. The basic principle is that when a liquid evaporates at reduced pressure, it cools. That is the basic principle. Evaporation causes cooling. So the evaporation of gases will causes the cooling, because when a liquid evaporates, it take up the latent heat either from the liquid itself or from the surrounding vessel. Oxygen and nitrogen can be liquefied by cascade process. In this case, a series of liquids with successively lower boiling point is employed so that the desired low temperature is attained. Joule-Thomson effect. This is another method to produce low temperature. If a gas is allowed to expand through a fine nozzle or a porous plug, so that it is used from a region at a high pressure to a lower pressure, there will be a fall in temperature of the gas, provided the initial temperature of the gas should be sufficiently low. This phenomenon is called the Joule-Thomson effect. What is the principle behind this Joule-Thomson effect means? It is the regenerative cooling. So regenerative cooling means it consists in cooling the incoming gas by the gas which has already undergone cooling due to Joule-Thomson effect. Okay, so here the previous gas is already undergone cooling due to the Joule-Thomson effect. So this is the experimental realization of Joule-Thomson effect. Here there is a two magnets and measuring coil, supporting threads, dewar flux, salt, liquid nitrogen, liquid helium. These are the parts of the Joule-Thomson apparatus. So the process is used to reduce the temperature of paramagnetic. It falls nearer to 0 Kelvin is adiabatic demagnetization process. We know that the molecular dipole magnetic moments of a paramagnetic specimen are randomly oriented at thermal equilibrium. In this state, there is maximum disorderliness of the system and its entropy is maximum. By the application of an external field, all the magnetic dipoles are aligned themselves in a common direction and hence there is an orderliness of the system. So the entropy of the system decreases and there is a rejection of energy. The heat is rejected by the specimen when it is magnetized is taken away by the surroundings and the original thermal equilibrium is restored. Therefore, the thermal motion of the molecules is unaffected if the specimen is now thermally insulated from its surroundings and the external magnetic field is switched off. That is adiabatically demagnetized. The magnetic dipoles again get random orientation in order to reach equilibrium, which is a state of maximum disorder. Therefore, the entropy of the system increases. When the entropy increases due to disorderly orientation of magnetic dipoles, there should be a corresponding decrease in entropy of disorderly thermal motion because the total energy in entropy during an adiabatic process should be 0. Thus, there is a reduction in thermal energy of the molecules and therefore the temperature of the specimen falls. Usually gadolinium sulfate, which is a paramagnetic salt, it is used for this experiment. It is placed in a tube which is immersed in a liquid helium bath of about 1 Kelvin and magnetized by the application of a strong magnetic field. By insulating the tube from the surrounding path and evacuating the tube, the specimen is adiabatically demagnetized. Now the temperature of the specimen is very much reduced. Temperature in the order of 0.002 Kelvin can be attained by this process. Thank you.